Welcome to today's session, children. In the last class, we have started with the need for the classification of elements, and you have also learned about the primitive classification given by Doberenger, which is known as Doberinger's Law of Triads. So the next classification which we will be learning today, it is known as Newlands Law of Octaves. So you can see a table here where Newland placed elements in total 7 groups. You can see 1, 2, 3, 4, 5, 6, 7. And there are total 56 elements in this table. So how did he arrange the elements in the increasing order of their atomic weights? In other words, in the ascending order of their atomic weights. So here total 7 groups are there, and in every group the elements are similar to each other in their physical and chemical properties. So he has given a law. So Newlands Law of Octaves, it states that every 8th element in the table repeats the properties of the first element. So every 8th element, so that's the reason octaves. It was oct means 8. So what does this law state? Once again I will repeat. Every 8th element in the table repeats the properties of the first element. So for example, we will start from hydrogen. Hydrogen 1, lithium 2, 3, 4, 5, 6, 7 and 8. So fluorine is the 8th element. When we are counting, so fluorine is the 8th element. So what does it mean? Hydrogen and fluorine will have similar properties. You can start from any other element. Start from, for example, sodium. Take sodium. 1, 2, 3, 4, 5, 6, 7, 8. So potassium is the 8th element for sodium. So potassium will resemble with sodium in chemical properties. So every 8th element resembles the properties of the first. Therefore, this statement, it is known as Newlands Law of Octaves. So in this table you can start from any element, count, go down in the vertical column and then go up and count. Everywhere 8th element will resemble the properties of the first element. So just like the music notes, you all know very well. What are the music notes? Sa, Re, Ga, Ma, Pa, Da, Ni, Sa. So Sa is the 8th note. The first note is Sa, again the 8th note is Sa. And the next scale will again start with the first note Sa. So just like that, every 8th element will repeat the properties of the first element. Right, even in the West we have the same scale or the notation. Every 8th note will resemble with the first note. Right, now he is the first one. Newland is the first one to introduce the concept of atomic numbers. He had given atomic numbers to the elements, but unfortunately his predictions or whatever he has published, it was neither accepted by the scientists nor the Journal of Chemistry, though he had contributed his best. Okay, coming to the limitations of this table. What are the limitations of Newland's Law of Octaves? Here, the first limitation is at some places you can see 2 elements are placed in the same slot. Can you see here? 2 elements are placed in the same slot. Here cobalt and nickel, they have the same place. Say both elements are having same slot. And you can see even elsewhere, iridium, platinum also are placed in the same slot. So this is one limitation. And the next limitation is, though he mentioned that the elements present in one single group resemble in the properties, some cases, at certain places, elements are differing in their properties with the other elements. Now for example, fluorine, chlorine, bromine, iodine, they have similar properties. Cobalt nickel, palladium, platinum, they have other properties. So this group, it differs from the other group. So this is one limitation. And here if you look at the table, he has completely filled without leaving any empty place for the elements to be discovered later. So only there is place for 56. So there is no scope to add any new element into this table. So these are the limitations of Newlands Law of Optics. So in the next session we will be learning about Mendeleev's periodic table.